All right. Again, good morning, everyone. So back to the beginning. So today we'll try to finish module number 6, which is about the principle of mathematical induction. So last time we have seen the idea behind the principle of mathematical induction, and we learned that this is a powerful proof technique that can be used whenever proving something is true for the set of natural numbers, or a certain subset or a certain form of subsets of the set of natural numbers. We learned na meron tatlong steps or tatlong mahalagang components ang proof by mathematical induction. Number one is the basis step. We want to show that the statement holds for the least natural number for which the statement is claimed. Usually, madali lang to. It's just a matter of substitution and a little bit of manipulation at most para mapakita na totoo siya for the least natural number for which the statement is claimed. So ito yung magiging simula ng chain of arguments natin na mako-cover lahat ng natural numbers for which the theorem is claimed. Number two, we have to state the hypothesis of induction. And this is very important kasi ito yung magiging key component or key ingredient dun sa proof natin o dun sa deductive step, right? So we assume that the statement is true for some natural number m satisfying the requirement of the theorem. Okay? So tapos, itong hypothesis of induction, siya yung gagamitin natin para magawa yung induction step. Meaning we want to show that P of m plus 1 is true provided that P of m is true. In other words, we're gonna show na yung hypothesis of induction ay sufficient na ipakita na kung totoo siya kay M, totoo siya dapat kay M plus 1. And we have seen several examples last time. So ngayon puntahan natin yung exercises kasi dalawa lang yung valid examples ko dun sa work text, dun sa module. So tingnan natin yung medyo siyam pala yung nilagay ko dito na exercises for PMI. And then problems 3 and 9 are in worksheet number 6, which will be due yung unang, kailan kaya natin to i-do? Meron na ba akong deadline ng worksheet 6 sa Canvas? I'm not sure if we already have a deadline for that.
In November
Pero siguro
12
let's
po.
put the deadline. Okay, thank you. So okay pa rin ba yung November 12? Gusto ko siyang in November 12. The reason is kasi sa week pagbalik natin ng reading break or from the reading break, November 9th, we will start a new study guide. So meron ng panibagong worksheet doon, worksheet 7, which you will submit on the 15th. So para hindi sila magsasabay. So okay pa rin ba 'yon, November 12th? Malay nyo, mabore kayo sa reading break, wala kayong magawa, maisipan nyo mag-PMI, pampawala ng bagot, ano. So, pero even if you will spend your reading break, relaxing, and then re-energizing yourselves, you still have the week of November 8 hanggang November 9 hanggang November 12 to finish it. I hope that's enough time. And if you have questions, feel free to send me an email or a chat via Teams during the reading break. I'll be more than happy to assist you. Pero again, you are not obliged to do anything during the reading break. Kung medyo na-bore lang kayo, gusto niyo ng discussion about Math 101, just feel free to hit me up with a message or an email, right? And I'll be happy to help you. Okay? All right, so let's see. Wala namang reklamo dun sa November 12. So let's see some examples here. Probably let's try problem number 1. Tapos, if you have other requests, sabihin nyo lang sa akin kung ano yung nafe-feel nyo dyan na medyo mahirap. Siguro yun yung sagutan natin after we do number 1. Except yung 3 and 6, kasi yung 3 and 6 ay 3 and 9. Siya yung gagawin nyo sa worksheet 6. So gusto kong i-attempt nyo siya with a fresh mind. Okay? Okay, let's try to prove this using PMI. So the statement is claimed for all natural number n So, ibig sabihin, yung pinakamaliit na natural number for which this statement is claimed is for n equals 0, right? So, because yung natural number system natin, kapag ka na we're talking about PMI, and for the rest of the module, makikita nyo na ang ginamit ng work text ay nag-start kay 0. Though usually, I start n by 1 or with 1. Ngayon, sundin natin yung work text, mag-start tayo sa 0. So, that will constitute the basis step. We want to show that P of 0 is true. Okay? Pero kung titingnan natin yung statement dun sa left-hand side, summation lang siya ng mga cubes ng mga natural numbers hanggang kay n cubed, right? Or in other words, na-encounter nyo na ba yung summation notation? We can write it in summation notation as summation of k cubed, k going from 0 until n. So si k lamang dito, ay papalitan natin ng mga natural numbers starting from 0 until n, tapos kunin natin yung sum nila. That's how we get this guy. But the right-hand side actually is the summation of k going from 0 to n, quantity squared, right? Kukunin muna natin yung sum ng mga natural numbers hanggang kay n, tapos kung ano man yung sum na makuha natin, i-square natin siya. So yun yung idea nitong statement for using summation notation. So usually it's quite handy to use the summation notation pag susulat nitong mga summation na ito. But the basis step is not much of a hassle. So P of 0 is true lamang. So ibig sabihin, sa left-hand side, kukunin lamang natin yung summation mula kay 0 cube hanggang kay 0 cube. So basically what we'll have for P of 0 is that 0 cube. And then we want to show that this will be equal to, may typo dito. Dapat nagsimula to kay 0. Lagyan natin ng 0 plus. Pabago yung problem 1. Dapat 0 plus 1 plus 2 plus 3 until plus n quantity squared. So, sulat ko lang siya dito. Ito yung problema ko na nahihirapan ako mag-shift from starting n from 0 vis-a-vis starting it from 1. So nakalimutan ko siya doon. Pero yung right-hand side is just the summation starting from 0 until n, tapos i-square natin yung sagot. But if we use n equals 0, so simula kay 0 hanggang kay 0, i-square natin, yun ay equal pa rin kay 0. Okay? So ibig sabihin, si 0 cube ay equal kay 0 squared equals kay 0. So therefore, the statement is true when n is equal to 0. Napaka-trivial niyang isulat, no? Pero hopefully, it's almost a gimme point. So dapat automatic makukuha niyo yung score para sa basis step, especially when you're dealing with 0 kasi quick substitution lang. And then the next step is write the hypothesis of induction. I suggest that you write the HOI explicitly kasi bibigyan ko siya ng points kung magpapa-problem set ako ng HOI, ng PMI, hahanapin ko yung actual statement ng HOI. Okay? So kaya isulat niyo siya. So can anybody spell for me what is the hypothesis of induction here? Any volunteers? All right, Mary Rose, go ahead. I saw you raised your hand.
Hi, sir. Can I try po?
Oh, sure. Go ahead.
Magiging, n is equal to m po. So, 0 cube plus 1 cube plus up to plus n cube, m cube po pala.
Okay.
Which is equal to the quantity 0 plus 1 plus 2 plus up to plus m close quantity squared po.
Okay, great. Thank you, Mary Rose. Pero training na rin, kompletuhin niyo yung sentence. Alright, so sa HOI sabihin natin, assume that for any or for some natural number m, kasi yung theorem daw totoo sa kahit anong natural number n. So sa HOI, ipapagpalagay natin na totoo siya para sa isang natural number na m, isang generic natural number m. Okay? Thank you. That's perfect, Mary Rose. And then, what do I want to show from here? Gamit yung HOI, ano yung goal natin na mapakita? Any volunteers? Okay, Mary Mitzi?
We want to show po that 0 cube plus 1 cube plus 2 cube up to plus m cube plus m plus 1 quantity cube equals sa sum po ng 0 to m plus 1 quantity squared po.
Okay, thank you, Mary. So, oops, hanggang m plus 1 and k quantity squared. Okay, or something like this, right? Pinaghalo namin yung summation notation at saka yung usual notation, which is perfectly fine. Okay, so let's see here. So ito yung gusto nating ipakita. Lagay ko lang siya sa box para ano lang siya, parang scratch work lang siya. Hindi siya part ng proof so far. Okay, oops, sorry. What happened? Anong meron sa umagan to? Parang napaka-clumsy ko sa devices ko ngayon. Sige, i-box ko na lang siyang ganyan. Okay, so ngayon, i-compare nyo yung HOI dun sa WTS. The goal is, from the HOI, pwede natin gamitin yung equation na nasa HOI. Pwede natin itong gamitin kasi assumption siya. Part siya nung conditional statement na gusto nating i-prove. Siya yung premise. And then from here, we want to get this one. So what do you think should be done next? Ano dapat yung susunod kong gawin? Preferably with the HOI, so that we will be closer to what we wanted to show. Any volunteer? Ano kaya pwede kong gawin dun sa HOI para mapakita or para mapalapit dun sa WTS? Anyone? Medyo mahirap pa siyang i-imagine. Oh, yes, Rhea.
Try lang po, sir.
Oh, sure. Go ahead. Shoot.
So, yung sa hypothesis of induction po, for some element po siya ng natural number. Next po, mag-a-assume po tayo ng m plus 1 po.
Aha. Ano yung gagawin ko kay m plus 1?
Yun naman po yung kumbaga yung sa 1 to show po, yung mula 0 cube up to plus m cube po, isa-substitute po yung value nun, which is yung quantity 0 up to m squared po, tapos plus m plus 1 cube.
Okay. So, yeah, that's right, Rhea. I-rephrase ko lang ng konti. So, sinasuggest ni Rhea, I think, ay mag-add ng m plus 1 cube. Tama ba? Which I think the reason for why she suggested that, nakita niya na, tingnan natin tong left-hand side. Summation mula kay 0 cube hanggang m cubed. Pero itong nasa kanan, itong nasa WTS, ay summation hanggang kay m plus 1 cube. So, ibig sabihin, short tayo dito ng m plus 1 cube. So, we can add that to both sides of the equation and hopefully from there, we can get the right-hand side. Okay? Kasi doon, pag nag-add pa lang tayo ng n plus 1 cube, makukuha na natin yung left-hand side ng WTS. So, in particular, this is what I think Rhea is going for. So, ito yung HOI, pwede siyang gamitin kasi part siya ng assumption. Tapos, para maging kamukha siya nung nasa WTS, mag-a-add ako sa kanya both sides ng m plus 1 cubed. Alright? So, solve na tayo dun sa left-hand side. Wala tayong problema dun. Kasi ito ay kamukhang-kamukha na neto. Right? So, ang problema na lang natin is, how can I write this as sum ng 0 hanggang m plus 1 quantity squared? So yun yung magiging challenge natin dito, right? But medyo may trick na kailangan gamitin dito. Okay? Now, gagamitin ko yung theorem na na-prove natin from last time. Remember this guy? Tandaan nyo ba, ano yung sum ng 0 hanggang m? Can you recall what that quantity equals to? I think we have proven this last time, also under PMI. So makikita nyo dito sa PMI, pwede pa rin tayong gumamit ng previous results. Okay? All right. Pero I think Mary Mitzi, kasasagot mo lang, no? So, sige, try muna tayo sa iba. Otherwise, I'm gonna call you Mary Mitzi. Anybody else who wants to try? Kasi napakalayo nito dun sa gusto kong ipakita. Tingnan niyo yung right-hand side. Gusto kong ipakita na ito, yung left-hand side, ay equal sa sum mula kay 0 hanggang m plus 1 quantity squared. Kaya lang, ang nakuha natin from the previous step ay pag-add ng m plus 1 quantity cubed. Alright? So from here, we should utilize some of the tools that we have already proven, right? And I guess since there are no volunteers, so Mary Mitzi, any suggestion? Yan pala, last minute. Sorry, Mary Mitzi. Unahin ko si Gad.
So yun po ba yung n times n plus 1 over 2?
Okay, great. Thank you, Gad. That's right. Itong summation na to, yung 0 hanggang m, na-prove na natin last time na ang sum ng first n integers ay n times n plus 1 all over 2. I think this is example number 1 if I'm not mistaken. So, kung i-apply ko siya kay m, kasi sum naman siya mula kay 0 hanggang kay m, siya ay magiging m times m plus 1 all over 2. But that is just this guy inside the quantity to be squared. Okay? So, itong sum na to, napalitan nito by example number 1. Tapos, quantity squared siya. Para dun sa quantity squared dito kanina. And then we'll have m plus 1 cubed, right? And the reason here is by, hold on, scroll up ko lang ng konti para ma-sure ko na siya example 1. Yes, that is example number 1 from last time. So let's just cite that, okay? So this is true by example 1. Okay. Move ko lang yung equal sign para magkasya. Okay. Maganda tingnan kasi kung tapat-tapat lahat ng equal signs. So, gawin ko siya rito para magkasya yung manipulation natin. Okay. All right. And then I'll try to simplify this, and hopefully at the end of the day, I can simplify this guy into this form. Summation mula kay 0 hanggang kay m plus 1 quantity squared, because that's what we want to show. So here I'll have what? I'll have m squared times m squared plus 2m plus 1. So dahil naka-square to, naka-square yung buong fraction, bawat factor niya ay may square. So you'll have m squared from there. And then m plus 1 quantity squared is simplified this way. It's going to be m squared plus 2m plus 1 all over 2 squared, which is 4. And then we will expand m plus 1 cubed using special products again. That's going to be m cubed plus 3m squared plus 3m plus 1. Okay? Okay ba yung algebra? Bantayan niyo yung algebra ko kasi maaga pa. So I hope I will not commit any blunder here. Okay? And then kapag sinimplify natin to, we'll add these two fractions together. What we'll have is, let's see, m to the 4th plus 6m cubed plus 13m squared plus 12m plus 4. Okay, so what you'll do to get that is to multiply this out. Kaya ako nagkaroon ng m to the 4th. And then I will have m squared times m squared is m to the 4th. Wala namang m to the 4th dito sa kabila. And then m squared times 2m, that's going to be 2m cubed Tapos ito, meron akong m cube. Pero itong m cube na to, mamumultiply ng 4 kasi wala siyang denominator na 4. So para makuha yung LCD. So essentially what I'll have from the second term is 4m cubed. Kaya ako nagkaroon ng 6m cubed. Similarly, I'll have m squared times 1. So I'll have an m squared here. I have an m squared over here, but that is a 3m squared, but that is to be multiplied by 4. So we'll have a total of 12m squared on the second term, all over 4. And then when we add them up, we'll have 13m squared, and so on. Okay? So meron kang over 4 dyan. Okay? And then this can be factored as what? This can be factored as m plus 1 quantity squared times m plus 2 quantity squared all over 4. Okay? Double check nyo na lang. Pag in-expand ko to, magiging equal dito. Okay? So ano lang siya, factoring this completely, makukuha ko ito. And then I can write it as a square. This would be m plus 1 times m plus 2 all over 2 quantity squared. All right? And then do you guys recognize this, the one inside the square? Does that look familiar? Ano yung m plus 1 times m plus 2 all over 2? Nakikilala niyo ba siya?
Yes po, sir.
Aha, nakita ko nag-raise ang hand yung mga nakasagot na. Okay, let me see. Sige nga, Rhea, nakita ko nagtaas ka ng kamay. Does this look familiar? Ito naka-highlight.
Similar po sa n times n plus 1 all over 2 po.
Okay, great. Yeah, that's right. Parang ano lang siya. Tama siya. Ang form niya ay n times n plus 1 all over 2. Pero yung n, pinalitan ng m plus 1. So pag pinalitan nyo si n ng m plus 1, you'll get m plus 1. And then if you replace n plus 1 or n here by m plus 1, we're going to get m plus 2. But this guy, what is this guy? What does this stand for? Ito ay sum mula kay 0, 1, 2, hanggang n. So ibig sabihin, the one inside the parentheses here, or the big parentheses, is the sum from 0 until m plus 1, right? Ito yung nasa induction step natin from example 1 dun sa proof natin by PMI dun sa example 1. So this is 0 plus 1 plus until m plus m plus 1, okay? That's what is being represented by that fraction over there. Siya lang yung summation na yan. Again, by example 1. And then may quantity spared na left over, so sulat natin siya. So by example 1. And incidentally, this is the form that we wanted, right? If you go back to what we wanted to prove, we want to show that the sum starting from 0 until m plus 1, quantity squared, is equal to this guy. And what we have shown is that that guy, the left-hand side we want in the WTS, is simplified through a series of manipulations until the sum of the m plus 1 quantity squared. Okay? And then that ends the proof. So we can conclude by the principle of mathematical induction, yung summation ng k cube, k from 0 to n, ay equal lamang sa summation of k from 0 to n, quantity squared. All right. Gad, you have a question?
Yes, sir. Sir, ask ko lang po,
Ano?
yung last part po, hindi ko po naintindihan kasi kanina, sir.
Which one? This one?
Yan po.
Okay. So, ayan, balikan natin. Medyo tricky nga ito, no? So, tingnan nyo itong nasa loob ng square, yung m plus 1 times m plus 2 all over 2. Sabi nga ni Rhea, ito ay kamuka nung n times n plus 1 all over 2, right? Tapos alam natin yung n times n plus 1 all over 2, siya yung sum mula kay 0 hanggang kay n. Alright? Pero sabi ni Rhea, etong nandito ay parang katulad nito, yung mga n's lamang pinalitan ng m plus 1, right? So if you replace this n by m plus 1, you get m plus 1. If you replace n in the second factor by m plus 1, so magkakaroon ka ng m plus 1 plus 1, magkakaroon ka ng m plus 2. Alright? All over 2. So ibig sabihin, ito pala, this represents the sum starting from 0, 1, 2, hanggang kay m plus 1. Alright? Kasi pag ito sinamation mo, gamit yung formula na derived natin sa example 1, ito ay m plus 1 times m plus 2 all over 2. So that means I can replace this boxed expression by this sum. Yun yung nakuha ko dito sa step na to. Tapos naka-square dapat siya sa labas. So kinopya ko lang yung square sa labas. Okay? Does that make more sense o mas nakagulo ba?
Okay na po, sir. Thank you po.
All right. So the lesson here is, pwede pa rin tayong gumamit ng mga previously proven facts or statements para sa loob ng isang PMI. So yun nga lang, iba yung format natin pinuprove. Pero kung makikita nyo, ang pinuprove pa rin natin sa induction step ay isang conditional statement. At sa pagpuprove ng conditional statement na to, of course, we will use the hypothesis of induction. Pero kung paano natin ipuprove yung conditional statement na yon, pwede tayong gumamit ng kahit na anong technique na natutunan natin mula dun sa mga previous lessons sa pagpuprove ng conditional. Pwede ka mag-direct proof, which is so far what we have been using. Pwede ka rin mag-proof by contraposition. Kung mahirap i-prove yung P of M implies P of M plus 1. Pwede mag-contraposition. Prove mo yung not P of M plus 1 implies not P of M. Okay? Or, pwede rin naman mag-proof by contradiction. Suppose P of M plus 1 is false. And then we want to draw up a contradiction. So, ganun pa rin. Carried over yung mga natutunan natin before, it's just a coincidence na ang ginagamit ko so far ay puro direct proof. Kasi usually sa PMI, direct proof naman talaga. Nahuhugot yung P of M plus 1 mula kay P of M. That's very characteristic. But in rare instances, pwedeng, baka kailanganin natin ng ibang proof technique para dun sa induction step. Alright? Yeah, that gave me an idea. Siguro sa problem set, mag-iisip ako ng isang theorem na kailangan niya mag-proof of proof by contradiction dun sa loob ng PMI. So just to remind you how proof by contradiction works. All right? Okay, let's see. Do you guys have other questions? Kasi susunod ko nang tatanungin ay, ano dito sa mga sumusunod na problems ang gusto nyong i-prove natin?
Attitude, Kuya Joe, sa totoo lang, nag-chat sa akin yung mga tiyahin na nandito sa April.
Yes, who's trying to speak? Dad?
Dapat lang. Lahat naman ay
Pwede po kayong tanong sa kayo po, kailan nyo po
Nandili po sa bahay, naglalaba.
best ginagamit yung PMI po? Kung mayroon po
Kailan
ba?
best ginagamit yung PMI? Yeah, that's a good question. Usually, siya yung go-to proof ko kapag meron akong statement about natural numbers. Kasi dun lang naman siya applicable talaga, yung PMI, kapag ang statement mo ay about natural numbers. And it's a good practice na siya yung ginagamit. Okay, pag nakakita kayo ng statement na this statement is true for all natural numbers, at least ako, my go-to type of proof is PMI. Pero yung iba kasi hindi naman nangangailangan ng PMI. Halimbawa yung example 7. Yung example 7 or yung exercise 7, kaya ko siyang i-prove directly. Hindi ko kailangan ng PMI. Pero pwede rin siyang i-prove by itong number 7. Try natin. Kaya ko siyang direct proof. Paano magiging direct proof nito? Probably I can write it here. Proof. So let n be a natural number greater than or equal to 1. So this is my specification of a generic element of n. And then I'll try to look at ln of n factorial. So sa direct proof na to, kaya kong ipakita or kunin yung left-hand side mula sa ln of n factorial. Okay? Ano nga ba yung ibig sabihin ng n factorial? Ibig sabihin ng n factorial, nagmumultiply lang tayo mula kay 1, 2, 3, hanggang kay n. Alright? Tapos, tandaan nyo ba yung loss of logarithm? Saan equal yung logarithm ng product? Or tandaan nyo ba yung ln x times y? Saan to equal? Yes, Rensis?
Natural log of x plus natural log of y.
Okay, great. So kapag ka meron kang, thank you Rensis, pag meron kang product sa loob ng natural log, pwede siyang maging sum ng mga natural logs. So ito ay isang katutak lamang na products. So pwede ko silang split down into a summation, right? So ibig sabihin, itong current right-hand side, pwede kong isulat as ln1 plus ln2 until plus ln n. In summation notation, this is just the sum of ln j's, j going from 1 until n. Kunin niyo yung isang term sa summation at makikita niyo nag-start siya sa 1, 2, nagtapos siya sa n, kaya yung summation ko from 1 to n. And actually, that's what we wanted to prove. End of proof na to. Okay. Pero pwede rin naman natin siyang gawa ng PMI version. So, siguro, try natin siya use. Oops, that pala hindi ko siya binara. Pwede natin siyang gawa ng PMI version. Okay, yung proof. Kaya lang makikita nyo mas mahaba. Ito siguro yung counter example dun sa sinuggest ko kanina kay Gad when he asked kung kailan magandang gamitin yung PMI. Sabi ko, ginagamit ko siya lagi kapag ka may statement ako about natural numbers. Pero example number 7, apparently is a statement about natural numbers and yet, mas madali yung direct proof. Okay? Pero pwede natin siyang gawa ng PMI version. So, proof by PMI. Pakita nyo, mas mahaba to kesa dun sa direct proof na ginawa ko kanina. Okay? So, I will let n, sorry, hindi ko na pala kailangan mag-let ng n. So, diretso ako sa basis step. Sa basis step, kailangan nating ipakita na yung statement is true for the least natural number claimed. Sabi ng theorem, totoo siya sa lahat ng n greater than or equal to 1. So, kailangan nating ipakita that p of 1 is true. Right? This is what we wanted to show here. Pero ano lang ba yung p of 1? So, ibig sabihin, ito ay, pag kinuha natin itong summation na to, summation lang siya starting from j equals 1 until j equals n. Pero ang n natin dito ay kay 1. So, ibig sabihin, itong left-hand side na to ay masisimplify as the sum from j equals 1 until 1. Si n, pinalitan lamang natin ng 1 kasi si 1 yung pinakamaliit na natural number for which the statement was claimed. ln of j. Tapos si-expand ko to. Si j, pwede kong palitan ng natural number starting from 1 hanggang kay 1. So, ibig sabihin, nag-iisa lang siya dyan. Alright? Pero si 1 na nasa loob ni ln, ay pwede kong isulat as 1 factorial. And essentially, this is the specification of the right-hand side to n equals 1. And there we can put a period kasi na-prove natin na totoo yung statement sa n equals 1. And then for the hypothesis of induction, I will consider a natural number m greater than 1 such that this statement is true. Yung summation ng ln j starting from 1 until m ay equal daw kunwari kay ln of m factorial. Okay? And then from here, we want to show that the summation of ln j starting from 1, but this time it will end at m plus 1. So lahat lamang ng m kay HOI, papalitan lang natin ng m plus 1. Ibig sabihin, yung nasa loob ni ln dun sa kanan, magiging m plus 1 factorial na. Alright? So yan yung gusto nating ipakita. Okay? But we will start with the hypothesis of induction. So what do you think should be done dun sa hypothesis of induction para makarating tayo or lumapit tayo dun sa WTS? Any suggestion? Oops. Okay, Mary Mitzi, kahit second time around mo na, yes?
Ayun po, ano po, di ba po yung ln ng m factorial ay summation po ng ln from 1 to ln of m? Plano ko po sana mag-a-add po ako ng ln of m plus 1 dun sa right side po na equation.
Okay, yeah, that sounds a good plan, except Mary Mitzi, alam ko yung gusto mong sabihin, pero i-clarify lang natin, mag-add tayo to both sides, right? Bawal ka mag-add sa isang side lamang, okay?
Ayaw pa.
Okay, but I know what you meant. Pero careful pag sinulat mo yan sa problem set, maminusan kita kasi mali yung statement, right? But I know where you want to go. You want to add ln of m plus 1 to both sides. So let's do that. ln, So galing na pala to dun sa HOI. Then we can say na kung totoo yung HOI, pwede ako magdagdag dito ng ln ng m plus 1. Pwede ako dito magdagdag ng ln ng m plus 1, which is perfectly fine because then, etong left-hand side ay magiging summation na lamang mula kay 1 hanggang kay m plus 1, right? Kasi ito ay yung additional addend natin ay this form except that j was replaced by m plus 1. So pwede ko siyang isulat in a more compact way by including m plus 1 dun sa summation. Okay? Tapos ito yung mangyayari. Oops, sabi nga kanina kalimutan ko kung sino yung nag-remind sa atin ng property ng logarithms. Kapag ka naman ngayon pabaligtad, meron kang sum ng logarithms, logarithm lang siya ng product. So what will happen here is we'll have ln ng m factorial times m plus 1. I think Rensis is raising his hand. Do you have a question, Rensis?
Sir, wala po.
Okay, yeah, no problem. So nakalimutan lang ibaba. And then, ano yung mangyayari dito? Nakita ko kanina si Daniel Noel nagtaas ng kamay. So Daniel, you wanna help me? What will happen to this guy inside the natural log?
It will simplify to m plus 1 factorial po.
Okay, thank you, Daniel. So that would be m plus 1 factorial, right? Kasi ito ay product mula kay 1 hanggang kay m. Multiplyan mo pa siya ng m plus 1, makukumpleto na yung m plus 1 factorial. And here we have shown yung induction step. Totoo yung p of m plus 1. And by PMI, we can say that ends the proof. Okay? Which I think is this proof by PMI is much more longer than what the direct proof from the direct proof that we have gotten earlier, right? So yeah, medyo thread between the lines. Talagang, papakiramdaman nyo talaga yung theorem. So yeah, minsan madali yung PMI, minsan mas mahaba siya kaysa dun sa direct proof. But I think you see that the main property that was used in both direct and the proof by PMI would be yung properties ng logarithm. So ganun lang naman, paglalaroan niyo yung mga konsepto na yan. Right? So it's already time, but do you mind if I borrow 10 more minutes para lang matapos ko yung isa pang example? Probably let's try example 4. So madali lang din naman siya pero para medyo may guide kayo dun sa gagawin niyo sa exam sa worksheet 6 which will ask you to answer problem number 3. Okay. But actually medyo corny itong problem number 4. Pero it would be a nice review of divisibility or the idea of divisibility para may springboard kayo para sa problem number 3. You'll do something similar but not exactly the same. Okay, pero yung general principle ay ganito. So for all n greater than or equal to 1, we want to show that 6 to the n minus 1 is divisible by 5. So let's try to prove it by induction. O sige, try muna natin yung direct proof. Kung gusto nating ipakita that 5 divides 6 to the n minus 1, medyo mahirap to kasi ano lang bang alam natin about 6 to the n minus 1? Ang alam lang natin mula kay 6 to the n minus 1, pwede natin itong isulat as 6 times 6 times 6 times 6 times 6 n minus 1 times. Okay? Or you can say this is what? This is 2 times 2 times 2 times 2 n minus 1 times 3 times 3 times 3 n minus 1 times. Right? Kasi bawat magka-partner dito magbibigay sa atin ng 6, makukuha natin yung 6 to the n minus 1. Okay? But the theorem is asking us to show na yung 6 to the n minus 1, kahit ano pa si n, basta siya ay greater than or equal to 1, lagi daw siyang divisible by 5. Actually, wait. Ito ba itong statement na to? Parang mali pala yung statement. Ano? Kapag kasi n ay 1, magkakaroon ka ng 6 to the 0. So that's gonna be, yeah, may problema tong problem na to. Hold on. Kasi magkakaroon ka ng, kapag kasi n ay 2, 6 to the n, 6 to the 2 minus 1, so magiging 6 siya. Hindi naman siya divisible by 5. So I think may typo dito, a very big typo, a glaring typo. So I think this is 6 to the n minus 1. Dapat yung minus 1 ay nasa baba. Try natin. Kapag kasi n ay equal kay 1, magkakaroon tayo ng 6 to the 1 minus 1. Equal siya kay 5. Okay, no problem with that. When n is equal to 2, we'll have 6 to the 2 minus 6 squared. 6 to the 2 minus 1 sa baba. So that's going to be 35, divisible by 5. And then n equals 3. Ano ang 6 cubed? 36 times 6. 6 cubed by 216 minus 1. So 215 divisible by 5. Kapag kasi n ay 4, 6 to the 4th minus 1. Ano ang 6 to the 4th? 1296 minus 1, 1295. So yeah, mukhang may typo dito. Pakibago naman sa worksheets niya, sa copy niyo. Dapat siya ay 6 to the power n, tapos kung ano man yung power na yon, minus 1. Dapat si minus 1 nasa baba. Okay? So let's try to prove it. Medyo mahirap siyang i-prove directly kasi ang itsura ng 6 to the n minus 1 ay 6 times 6 times 6 times 6 times 6 minus 1 n times. Hindi ako makakapag-factor dito ng 5. Tama? Kasi ang factors lang naman ni 6 ay 2 at saka 3. There's no way I can factor a 5 here. Also, there's no way I can factor a 5 out of 1. So, ibig sabihin, hindi ko siya kayang i-prove directly by factoring out the 5 using only the definition of 6 to the power n. And this is one thing, or one instance wherein PMI would be more helpful. Okay, so let's try to prove it using PMI. And again, I start with a basis step. For the basis step, we want to show that P of 1 is 2, because 1 is the smallest natural number for which the statement was claimed to be true. Okay, so let's simplify 6 to the n minus 1. When n is equal to 1, we'll get 6 to the 1 minus 1. So that's going to be 6 minus 1 equal to 5, which is divisible by 5. And that proves the basis step, right? Or that concludes the basis step. Okay. The next, let's state the hypothesis of induction. Can somebody help me with the HOI? Ano dapat yung HOI? Talagang ayaw niya sumagot pag obvious, ano? Sige, Daniel, kahit nakasagot ka na. Mhm.
6 to the power of m minus 1 is divisible by 5
Okay,
for
great.
m
So,
for some m.
okay, thank you, Daniel. Yeah, that's right. Suppose we will suppose that for some m greater than or equal to 1, 6 to the power m minus 1 is divisible by 5. Okay. Then what's my WTS? What's my goal? What do I want to show? Dapat ano tayo, lightning round kasi patapos na yung oras. Any volunteers? Sige, si Daniel na lang uli. Ayaw nung iba eh. Go Daniel. What's my goal? I want to show that.
We want to show that 6 to the power of m plus 1 minus 1 is also divisible by 5 po.
Okay, so 6 to the power m plus 1 minus 1 is divisible by 5. Or, dun sa natutunan nating bagong symbol last time, 5 should divide 6 to the power m plus 1 minus 1. Okay? Now, so we will show this using the hypothesis of induction, all right? So, kailangan mapakita natin na 6 to the m plus 1 minus 1 ay kayang isulat as 5 times some integer, right? So, gagamitin ko yung HOI. Sabi ng HOI, 6 to the power m minus 1 is divisible by 5. So, we know that there exists some integer q such that 6 to the m minus 1 is equal to 5 times q. Right? Ito yung alam natin. Now, how can I go to paano ko makakapunta kay 6 to the power 6 to the power m plus 1 minus 1 mula kay 6 to the power m minus 1? Kailangan ko ng expansion para kay 6 to the power m minus 6 to the power m plus 1 minus 1 para makarating dun sa 6 to the m para mapakita na divisible siya. Yes, Victor Luis?
Sir, can we try na mag-multiply ng isang 6m?
Isang 6m. 6m bang buo?
Ay, 6 to the power
Or
of m.
6 to the power of m. Medyo sa sobra yata kung 6 to the power m yung i-multiply ko both sides. But I guess I know what you're trying to do. Kasi ito meron tayong 6 to the power 6 to the power m lamang. Pero dito gusto natin 6 to the power m plus 1. So kaya gusto mo mag-multiply para makarating dito, right? But I'll hold on that thought, Victor. Ma-modify lang natin siya ng konti. Let me see. Mary Mitzi, meron kang suggestion?
Mag-multiply po ng 6 both sides. Tapos magiging 6 raised to m plus 1 minus 6 po yung sa left side. Tapos magiging 5q times 6 po yung sa right side. Then, yung minus 6 po, gagawin pong minus 1 minus 5 po.
Okay, great. I think that's the way to go. Thank you, Mary Mitzi. Thank you also, Victor. Victor, counted yung na recitation mo, so comment ka mamaya. So yeah, I'll try to do what Mary Mitzi suggested. Pero Mary, ano ko lang i-modify ko ng konti. Siguro mas madali siyang tingnan as, let's see. Inisip, sige, gawin ko na yung sinabi ni Mary. Mukhang mas madali siya dun sa inisip ko. So mag-multiply daw ako ng 6 both sides. So I'll have 6 times 6 to the m minus 1. And I think this is where Victor is trying to what he's trying to do earlier. So mag-multiply ako ng 6 to both sides. Okay? Tapos yung left-hand side, maging 6 to the power m plus 1 minus 6 equals siya kay 5 times q times 6. Okay? Everything is fine so far. But ang gusto nating ipakita si 6 to the power m plus 1 minus 1 ang divisible by 5. Kaya lang may panggulo pang konti dun sa kaliwa. So, ang kaliwa natin dito ay 6 to the m plus 1 minus 6. Gusto ko lamang ay minus 1. So, ang gagawin ko, mag-a-add ako ng 5 to both sides para yung negative 6 dito ma-reduce to negative 1. So, I will add 5 to both sides. Okay? And so, we'll get 6 to the m plus 1 minus 1, which is the number we are concerned with. Yan yung gusto nating ipakita na divisible by 5 ay equal kay 5 times q times 6 plus 5. And then definitely here, we can say it's 6 to the m plus 1 minus 1 sa baba ay equal kay, oh, you see here, first term, second term, parehas divisible by 5. So we can factor out the 5. This would be 6q plus 1, all right? But since 6q plus 1 is an integer, because q is an integer, then we can say na si 6 to the m plus 1 minus 1 is divisible by 5. And so therefore, by the principle of mathematical induction, we can say that 5 divides 6 to the power n minus 1 sa baba. End of proof. All right? So ito yung pwede niyong gawin whenever working with divisibility sa PMI. Okay? And you will see utility of PMI as we go along. So yeah. All right, so I think this is a good place to stop. Medyo overtime na nga lang, but I see some raised hands here. Daniel, do you have a question? Or nakalimutan lang ibaba?
None po.
Okay, thank you. Sige, si Mary muna tapos si Kat. Yes, Mary?
Pero hindi na dapat ako
Sir, tanong ko lang po dun sa HOI po, hindi na po ba natin kailangan sabihin na M is a natural number po?
Yeah, good point. Dapat sinabi ko siya, no? Pero kung understood na naman, pwede nyo na siyang hindi ilagay. Okay? So, pag nasa loob ng PMI, isipin ko na na-understood na natural number, yung M. Okay? Pero if you want to be strict about it, kung gusto nyo completuin, yeah, go ahead. Sulat nyo na si M dapat natural number. Pero sige, pag-usapan na natin yan, pag-agreehan natin by convention, kapag ka sa HOI o kaya sa loob ng PMI, nakakita ko ng N at saka M, lalo na dun sa HOI, assume ko na natural number yan. Okay?
Okay po sir, thank you po.
All right, you're welcome. How about Gad? May question ka, Gad?
None po, sir. Mag-request lang po screenshot.
Okay, yeah, no worries. Okay, so any other concerns or questions? Oh yes, so please.
Mamasahe ka lang, Kuya Jo. Ang pamasahe naman ay 300.
Sir, tama po ba ho ng pagkakaalala na nung last meeting po natin, sabi nyo, in doing the worksheets, hindi na po need ilagay or dapat hindi ilagay yung basis step or namali lang po ka ng dinig?
Siguro na mali ka ng direct or ng dinig or I misspoke. So, sa worksheets, kailangan nyo pang ilagay yung basis step. Kasi part talaga ng PMI. Okay?
Thank you po, sir.
Yeah. Yep, you're welcome. Another question, Victor?
Sir, so since we can use naman the old yung contraposition, contradiction, will there also be a time na maging by case rin siya?
Yes, that's right. So lahat ng natutunan natin na methods of proof ay posibleng lumabas dun sa induction step ng PMI. So you can think of PMI as a hybrid type of proof na ang ginagamit lang talaga natin ay yung principle ng mathematical induction. Pero sa loob ng paggamit ng principle na yon, yung mga methods of proof na natutunan natin before ay applicable pa rin. So kaya nga pwede ako mag-invento ng isang question sa PMI na covered na lahat ng methods of proof. So something like that. Kung gusto ko kayong i-terrorize. Palay nyo, makita nyo sa problem set 2, So yun. Okay. Other questions,
Sir.
concerns? Yes, that.
Sir, pwede pong paangat. Di ko po screenshot.
Okay. Number 4 ba?
Apo, sir.
Yan. All right. Other concerns, requests? Yes, Victor.
Sir, okay lang 'di ba maiwan sulatin pa rin namin ang WTS sa proof namin.
Yeah, okay lang na hindi niyo siya isulat. So, sinusulat ko lang siya palagi kasi mas visual ako. So, hindi ko alam, minsan nalo-lost ako kung ano yung gusto kong ipakita. So, gusto nakikita siya side by side with what I already have. But if you're
without,
comfortable
sir,
without
okay
seeing
lang.
the WTS, yeah, okay lang.
Okay, sir. Sige, sir. Thank you.
Pwede niyo siyang hindi isulat kung komportable kayo. Okay? May questions pa ba? Requests? Okay, if not, then thank you guys for joining me this morning. We had a good discussion. So I hope you enjoyed the rest of the day and of course the rest of the weekend. Tapos also the rest of the entire reading break. And let's see each other again. Matagal-tagal. We'll see each other again on November 9th. Tama ba? Okay, until then, guys, keep safe and enjoy your vacation. Bye, everyone.
Thank you, sir.
Bye, sir.